Kính chào quý vị. Tôi nói just một chút tiếng Việt. So I'm going to speak today to you in English. So I'm going to apologize for my poor Vietnamese skills, but I'm extra thankful to be speaking here. My first time speaking about blockchain, not just in Vietnam, but in this city of Da Nang. Because I actually am quite connected, and my family is quite connected to Da Nang. I was born in Saigon, the youngest of 4 children, to a family with 6 people total. And before my family left Vietnam in 1975, we actually lived here for 2 years in Da Nang when I was a little baby, so I do not remember any of it at all. And we did so because my father was a judge in Vietnam and was serving here at the courthouse in Da Nang for 2 years before our family's departure. And so much of my life story since my family moved to the United States in 1975 has been about connecting past, present, and future, and connecting lives and worlds. So much so that I connected with my family's and my father's legacy in the legal profession by going to law school in Los Angeles, graduating in the mid-1990s, right at the boom of the internet and the dot-com movement in Silicon Valley and the United States. And that is why my professional career has been defined by helping grow the power of internet and digital technology. As a lawyer, I represented everything from startup entrepreneurs to, by the end of my career, some of the biggest conglomerates in the world: Microsoft, Amazon, Uber, the major Hollywood movie studios, sports organizations such as Major League Baseball, and even the Miss Universe organization for beauty pageants. I did so because I saw the power of the internet to connect each other. And around 2009 and 2010, when Bitcoin and blockchain emerged into the world, I started paying attention. And over the years, I learned that blockchain technology is the next major data network that will transform the world to the impact that the internet did in the 1990s. And so that's why, about 6 or 7 years ago, I planned a departure from my life as a partner in major US law firms to join the blockchain world full time. Because I saw a connection between the past of the internet and the future of blockchain, and more importantly, that their combined power would be even greater. So that's what I've been doing for the past 6 years, leading the growth of blockchain technology, traveling the whole world with an organization like mine, which is based in Switzerland, but going to Australia, Canada, a lot of Asia, Europe, and a lot recently in the Middle East, Dubai, Saudi Arabia, Bahrain, even in South Asia, Pakistan, all regions that are very interested in the growth of blockchain technology to drive a more connected world. And I've tried to explain this to my parents. In fact, I was just at my parents' home in Southern California this past weekend, taking this picture with my dad, who knows I'm here on this trip to talk to you about blockchain technology, sort of understands what I'm going to talk about technically, but mostly knows that his youngest son is here to impart the knowledge I have learned from my journeys in the United States and across the world to help connect our birth country of Vietnam to a more modern future. And that is the future I want to talk about today: how to create one world connected. And more importantly, why that one world, really it'll be powered by the combination of IPv6 and blockchain. But not just any blockchain. The blockchain BSV, which I lead the global organization for, which was designed with its original Bitcoin protocol to actually interact and work with IPv6. I'm not the only one who believes this. Earlier today, you heard from Latif Ladid, who helps lead the global IPv6 forum. He also believes that BSV is the winning combination with IPv6. And so that's why we are proud with my association to partner with the IPv6 forum to lead educational activities like I'm doing today. Why does IPv6 have this power? It's 3 main reasons. 1, the ability to generate far more unique IP addresses than IPv4. Instead of 4 billion IP addresses, over 18 quintillion unique IP addresses capable in IPv6 to really connect end-to-end every human being, device, object, animal, tree, anything that you might think of in the world. Secondly, bigger data packets, which will power a much more connected world. And finally, achieving the dream that the early internet architects wanted, an internet that relies less on intermediaries and service providers, an internet where you can actually truly send peer-to-peer payments down to the tiniest level and data to really achieve the vision of what people today are talking about as Web 3. So to understand how this is going to be birthed by BSV, I need to explain to you that BSV stands for Bitcoin Satoshi Vision, a competing chain of the Bitcoin network that actually is trying to fulfill the vision of its mysterious creator, Satoshi Nakamoto, who, as Latif mentioned earlier today, is Australian computer scientist Craig Wright, who I've worked with for the past 6 years. When I say Bitcoin, people often get nervous around the world, especially governments, when I speak to governments across the globe. And I understand why. Bitcoin has created for itself a fairly negative reputation, especially because so much of the main version of Bitcoin you think about, BTC under its ticker symbol, is really not used for anything except for speculative investment trading, and has driven a cryptocurrency market, which I agree is bad and problematic. Too much focus on speculative assets going up and down. We are trying to change that and unleash the full power of Bitcoin's data network protocol at massive scale, so that it can be used to power billions of payment and data transactions across the world, to actually serve as its original vision, peer-to-peer electronic cash, but more importantly, to act as the infrastructure for distributed data, to work with the internet, to do something which has not been done yet, actually make blockchain useful for everyone. That's our vision for a connected world. And in my time today, I want to explain how this creates a unique opportunity, especially here in Vietnam, by first talking to you about the design of blockchain, secondly, why scaling blockchain massively is important with BSV, and finally, how this all relates to a better internet and data with a unique combination of IPv6. Bitcoin and blockchain is not just about investment trading. It was designed to solve this. This is an unused HTTP error code, 402, which was put into Internet Protocol by the designers of HTTP, but has never been used. Why has it never been used? The purpose of this code is to say payment required. You land on a website, you land on a web service, and to access the content or the service or the application, you need to pay somebody, something. The reason this has never been used is that Internet Protocol created a powerful way to send data across the world, email, social media, pictures, applications, but it does not have built inside it a native way to send monetary value. And that is why Internet Protocol never activated this error code, because no websites and no web destinations have a native way to accept monetary value. But the creators of Internet Protocol always envisioned this could be the case, including down to micropayments. And that, my friends, is what Bitcoin was actually designed to solve. This is the famed Satoshi Nakamoto white paper published to the internet in 2008. For those of you who've not read it, give it a read. It's not that long. And what it described is not digital gold, a speculative investment, store of value, asset, which people talk about now. It describes at its title a peer-to-peer electronic cash system, so that I could send from anywhere in the world, me to you as a peer, amounts of cash electronically. And the beginning of the white paper describes the need to solve the problem of being able to send money across the internet without intermediaries. Because the Internet Protocol does not have a native way to send money value, we had to layer on top of it credit cards, payment processing systems. In the United States, services like PayPal or Venmo, Alibaba in China. All of that adds extra layers of inefficiency, cost, trusting other people to keep track of the data and ledgers of payment. That is what Bitcoin was designed to solve, to actually make that error code 402 useful in the world. How did it solve it? There's ways to send money across the internet, but the problem that Bitcoin truly solved is what's called the double spending problem. How do I make sure that I am not sending the same amount of coin to two different people and spending it twice, which would be fraud? And it solved the problem by looking at research from the 1990s from two computer scientists in Silicon Valley, Stuart Haber and Scott Stornetta, who published these famed research papers in the 1990s by looking at what's called digital timestamping. They did so because in the 1990s, when the internet was emerging, they realized that more and more of our documents, our records, would become digital. How would we know that documents, a contract you sign, for example, is authentic, is accurate? And so they published these papers looking at how to digitally timestamp electronic records to verify their authenticity. And the reason this relates to Bitcoin is if you actually read the Bitcoin white paper and go to the very end at the footnotes, those 3 papers about digital timestamping are referenced in the Bitcoin white paper. Why? Well, this is how the double spending problem was solved. Bitcoin's white paper doesn't even use the term blockchain. That's the industry we work in today. But it uses the phrase distributed timestamp server, a system where I can record in a timestamp manner by date and time. I send 1 Bitcoin to you on today's date and time. You send half of it to this person. And therefore, we can track the chronological order to prevent cheating. And more importantly, it's distributed, meaning instead of one company like Alibaba keeping the ledger, it is published to the world, and many nodes or computing servers are involved in updating the ledger. By distributing a time-stamped recording of events in history, whether they be Bitcoin payments or other events. I sold my car to you. You sold your house to this other person. You create a system that prevents cheating, is more honest and more efficient. And that is by, instead of having one person in the middle keeping track of the ledger, you have a distributed system where many, many people are contributing to the updating of this ledger. That's what Bitcoin was designed to solve. And this is why, even though Bitcoin has discovered a very bad reputation for itself over the last 10 years, it actually was a system designed to create more honesty. The word honest is actually used in the Bitcoin white paper 15 times, something people don't realize. And this is how Bitcoin, with its distributed record of history, actually can create a more honest world and achieve something that we don't think about often enough. It is not a speculative investment asset. Instead, what Bitcoin is a solution to the internet's challenge of how to send money value. It's right there in the word bit, data, and coin, money. Bitcoin is a system and a network protocol for the fusion of data and money into one, to create a way to send data that has monetary value. It could be data that records ownership of a Bitcoin. It could be your consumer data, which right now social media services use without paying you for it. It could be your healthcare data. It could be any kind of data that has money value. And therefore, I'm here today to tell you, Bitcoin, in its original vision from Satoshi, was not meant to be a speculative investment asset. It's a peer-to-peer electronic cash system. It has a blockchain, which is its distributed ledger. Its programming language even has a very primitive programming function called script, which allows it to do computation, smart contracts, and tokens. It's a data network like the internet, and just like IP protocol governs the internet, it has its own network protocol, which defines how devices on the network communicate with each other. And this is how BSV relates to IPv6. Because with what we call our metanet, which is an advanced version of the internet we want to run on BSV blockchain, the blockchain can record not just Bitcoin amounts of money being sent around, it can timestamp data packets being sent across the network. It can chronologically order data packets. It can generate the proof of existence of documents at a certain point in time. You attend this conference, you get a certificate of attendance. It can record that and prove verifiably on a public time-stamped ledger the date and time of that proof of existence. It can ensure that records are not changeable, they're immutable, and provide a data layer that adds to the power of the internet. For this power to be fully unlocked, we need what I call a world of scaling. And this is why Bitcoin in its BTC form hasn't really been used for anything. People buy it hoping to get rich quick, which there's nothing inherently wrong with, but that's not what it was designed to do. Why? It's because the protocol developers who took control of the BTC network chose to not allow the Bitcoin network to scale. On average, every 10 minutes, a new block of data or transactions is added to the blockchain. The BTC network has frozen itself at 1 megabyte block caps with a capacity of what's called 4 megabyte block weights. That's very small. meaning its network does at maximum 3 to 7 transactions per second on the blockchain for the whole world, not just one person, the whole world. If Bitcoin was designed to challenge the Visa, MasterCard, or payment networks, there's no way it could do that when Visa and MasterCard are processing 2 to sometimes 50 to 60,000 transactions per second. So the solution is what we have done with BSV. Take the original Bitcoin protocol and just let it scale. With a lot of technical work and improvements by our development team, we've now been able to demonstrate that we're not going to control the network capacity. Let market forces do that, just like market forces increased internet data capacity. We have demonstrated through new software that's coming out this year, the ability for our network to do 50 to 100,000 transactions per second, to challenge the payment card systems, but more. Eventually, we want to hit terabyte-sized blocks, 1 million megabyte blocks, to power billions and billions of transactions across the internet. We're having success already with this. We've hit the world's largest blocks on any public blockchain on BSV. Whereas BTC is still at its tiny 1 to 4 megabyte blocks, we are now at 4 gigabytes. This is the world record block mined earlier on our network on April of this year. 4 gigabytes, that's 4,000 times the capacity of the BTC network. And we're able to process in one block several million transactions per second. But there's even more. Because the size of data is important. In the original Bitcoin scripting language, there is an opcode, an operating code called op push data 4, which allows you to push into one single Bitcoin transaction 4.3 gigabytes worth of data. 4.3 gigabytes worth of data. If Satoshi intended the block size of the whole network to say only 1 megabyte, why did he put this opcode into his protocol? He did it because he envisioned a world where Bitcoin's network would actually work with a larger version of IP protocol to push out bigger packets of data. And coincidentally, IPv6 allows jumbo packets of about 4 gigabytes of data, because this was planned. And this has a practical effect on the ability to use a blockchain, including for some of the uses that I'm seeing here in Vietnam, smart city and IoT usage. The reason people don't use BTC for daily payments is it's too slow and expensive. This is a chart of the transaction fees that you have to pay on the network to send a BTC transaction over the last year or so. As you can see, it's not just high, it's unreliable, ranging from about 70 US cents to sometimes over 30 US dollars to send one BTC transaction. This is not the way to create a global payment network if it costs that much money to send a transaction. And Ethereum was the main competing business blockchain, which people thought would be the one to be used for smart contracts and tokens. Its gas fees, what you have to pay to do a transaction, are even more high and unreliable, ranging to almost 70 US dollars at one point. If you were a big business or a government wanting to do massive blockchain applications, you cannot plan your business model if one day the transaction fee is $3, another day it's 70 US dollars. It's not reliable. Well, on BSV, because of our scaling and our big block size, to send a payment of any amount across the BSV network around the world right now costs about 1/100th to 1/20th of a US cent. 1/100th to 1/20th of a US cent, almost free. And we think that's even too high. We think it needs to go down to about 1/1000th of a US cent. And the reason this is important is to fulfill Satoshi's true vision, which is not to send huge amounts of money through the Bitcoin network, but to power small, casual transactions and micro payments across the internet and change the way the internet works. Instead of having an internet where your services like Facebook and Instagram are free to you, but they use your data to sell to advertisers, what if there was a different form of internet where you actually had to pay to tweet or to post, but you got paid back in small amounts of micro payments? It would change how everything works. And this is already happening on the BSV network. Handcash is one of the top mobile wallets on our BSV blockchain, founded by 2 Spanish entrepreneurs. This is a snapshot of my wallet. And as you can see here, people have sent me 1 US penny, a quarter of a US penny, just because they're trying to show their support and be a fan. And it's not because I need the quarter of the US penny. It opens your minds to what kind of business models can be created if you have an internet system with blockchain that can send transaction levels to that tiny, tiny amount. Imagine paying on toll roads in your vehicle for every kilometer that you drive. Imagine every time you access a security access point at a hotel or an airport with a security token where someone's exchanging small amounts of money to power that service. This changes the internet, and this leads me to my last section of this presentation, is how does this create a better world with the internet and IPv6? Well, as I mentioned, we could change how the internet works. No more free services. What if you actually had to pay to read something? Like, I don't like paying for digital monthly newspaper subscriptions. However, sometimes I run into an article, but I want to read that article right then. I don't want to pay for an annual or monthly subscription, but I would pay 10 US cents or 25 US cents that you could deduct immediately from my Bitcoin wallet. What if I had to pay for every minute of a video I watch online so that I didn't have to sit through ads? What if you didn't have to get free Google searches, you had to pay, but you got better quality search results because you don't have sponsored ad links? This is an imagining of how the internet could be different if it was monetized and there was a way to send small amounts of value. This also means there's new ways to earn. That hand cash wallet I mentioned has connected to it many apps, games, social media sites, where you actually pay to play a game, but you can earn small amounts of money back. They also have things like social media. Relica is an Australian team that's made essentially what's like Instagram, but with micropayments. Because with Instagram, even the top influencers do not make money directly from Instagram. But what if you actually paid to post your picture? If you had a lot of fans, every time they liked or responded to your post, they tip you small amounts of money. It creates new opportunities for influencers to get paid to create, even down to 12 cents, 10 cents, whatever you want to set as a creator. Haste Arcade is a startup in the United States, which has taken this into the video game world. Remember the days when you went to an arcade game, and in the US, we would stick a quarter into the machine and play. And if you got a really good score, you would get the top of the leaderboard, but you didn't make any money. Well, they've developed an SDK, a software development kit, and a platform that can connect with any online game. And you pay to play the game, and if you get on the leaderboard, every person who comes after you, if they do not beat your score, you get a tiny fraction of the amount they paid to play the game. It creates all new ways to earn of many types. CryptoFights is a big esports game on our blockchain in the United States, which uses the BSV network to make NFTs, avatars, virtual items, and to actually allow people to earn small amounts of money. This also means you can create business models as a government and private enterprise to create more financial inclusion, especially in developing countries. CentB is a company on our blockchain in South Africa, which has a remittance product called Minute Money, which makes it far cheaper to send money to family and friends across countries, especially which migrant workers do. They allow remittance across 8 African countries. Instead of charging 6 to sometimes 10% of the remittance amount, they charge a flat amount of 50 South African rand, which is about $3.17 US. So they take a fee, but the fee to the network, the BSV network, is so low, they don't have to take 10% of the money you're sending. This really opens up powerful financial inclusion tools such as Monetex, another company using our blockchain network to create digital lending and peer-to-peer micro lending in East Africa, starting with Uganda. So for people who want to start a small business, if you can't get a bank loan, you can raise money from your community, donating small amounts of money into a pool that they lend to you and you repay back to them in small micropayments. Again, the power of small micropayments. It means we can change how the internet works with your identity and data. In today's world, every time you log into a social media application like Facebook or Instagram or Twitter, they have your data. And therefore, you need to have access and authentication at each service. What if we changed it? A company in China is doing that with Meta ID, where your identity is managed in one place on a public blockchain. And instead of all those companies having your data, you authorize access to your data collected on one place in the blockchain whenever you use their application. It changes the architecture of the internet. With data integrity and sovereignty, you can have more power over your own data as a consumer. VX Technologies is a company in the United States which has built a COVID-19 vaccination tracking platform using our blockchain to track by date and time when you got your COVID vaccination shots. You have control over the verified health records. You get to authorize when some government, when some airport, when some hospital accesses the data. And it gives you the ability to make money in small micropayments if someone wants to access the data from you. This means we can create a world of verifiability and traceability. As I mentioned, blockchain is a public ledger. It's a time-stamped server recording events in history. Unisat is a Norwegian company using our blockchain to improve supply chain, the tracking of seafood, of Norwegian salmon. They're now working on projects to track art and the journey of fine art and the provenance of art through the blockchain. They're also working with Local to Local, an organic local farming company, to be able to track the journey of organic food from the farm to a restaurant to your table. And in the UAE, Latif Ladid mentioned this. We have a project going with the University of Sharjah near Dubai to actually build a platform that tracks academic credentials and professional certifications on blockchain to prevent fraud, because people do lie about their degrees, or to provide easier and faster verification when employers trying to hire you or someone's trying to verify when you got your degree, when you got a certification, and whether it's valid or not. And this leads to a world that is much more connected in the digital age. This is a snapshot of trees in the city of Cairns in Australia, where an environmental consulting firm is working with our blockchain to put IoT devices on the trees and to record to our blockchain environmental information about the carbon sequestration data of the tree to improve environmental sustainability goals in the city. IoT devices sending smart data to a blockchain where it creates a public marketplace to improve environmental conditions. This is all done with an Australian company that has a wallet called MetaStream, which powers the sending of huge volumes of data to a blockchain. They needed a blockchain that could handle huge amounts of data, fast speed, for very, very low cost. You cannot do this if it costs $70 per data event. You can't do it if it costs only a penny. This will also change identity biometrics. This is a video from a company formed by a friend of mine out of Dubai called Palm Fusion, which takes biometric screens of your hand and attaches that to your identity. And it allows you to maybe one day pay at a grocery store with a scan of your hand, because it verifies your identity. They're not currently using blockchain, but they're working with our organization and one of our key companies to integrate this technology to blockchain so that every validation event is time-stamped in history on a publicly verifiable ledger. This technology can also be used to do things like enter into a room and validate security access at important places or at offices, so you can verify when people go in and out of a building. It can also be used to even automate the driving of smart cars and validate every event that happens when you get in and out of a car. Why blockchain is important is because of the authenticity of the information that can be publicly verified. And this is why IPv6 is so important. 128-bit address system, over 18 quintillion unique IP addresses. You can uniquely assign an IP address for every person, animal, object in the world. So when we talk about the future of smart cities and devices, your belt, your clothing, your dog collar may have smart connected devices. And this is why BSV is working with the IPv6 Forum to enable a world where not only can you transmit data, but all of those devices can transmit micropayments, microtransactions, tokens to validate your identity. That is the world I see coming. And it will finally lead to an immersive world of metaverse. Everyone's talking about metaverse. This is a digital twin scan of Los Angeles from a company in the US called Transmira, working on our blockchain. They'll be using this to create metaverse experiences where you can go to school in this digital twin, you can go see your doctor, you can watch a concert. They needed a blockchain that can hold a big amount of data to power monetary transactions in this virtual world, and they chose BSV to create a more connected world. This is why I see such great power in BSV and the combination with IPv6. And I know it's a big vision, which is connecting the whole world through many, many devices and micropayments that change how our internet and how our daily lives work. But it's a world I want to see come, at least in part of my lifetime, because it carries forward a lot of the lessons that I have learned from my journey from Vietnam to the United States, which is how to connect the past, the present, and the future. And I'm hoping my parents get to see part of it as well. I know it's a big vision because it's a vision for blockchain and the future of internet. It's a vision for one connected world with data and micropayments that are truly peer-to-peer. Bitcoin and its blockchain were introduced to reinvent internet payments with a distributed ledger of transactions. Transactions organized into blocks connected across time. But those blocks contain more than just payments. They contain the one most valuable commodity of our digital era, data. And therein lies Bitcoin and blockchain's bigger vision for the internet, the fusion of data and money into one protocol that makes applications better for consumers, business, and government. One universal source of truth that opens data transparency and breaks down data silos. One timestamp ledger that traces our products, assets, and the very sustainability of our planet. One network that makes our devices, communities, cities, and nations smarter, more autonomous, more powerful. One system with blockchain and internet that connects everything, everyone, everywhere. Whether you're from Australia, South Africa, the United Kingdom, USA, or places I've been like Pakistan, Saudi Arabia, United Arab Emirates, or here in my birth country of Vietnam. If you combine IPv6 and the BSV blockchain, we'll build one world connected.